You remember people used to test batteries by their tank?
Yeah.
Ever heard of somebody saying, I'm getting shocked by everything in my house?
Yeah.
You touch a sufuria,
Yeah, you're shocked.
You require actually 1/10 of amperes
To be
to
shocked.
kill you. As long as you hold on it for more than, say, 30 seconds.
Oh. Welcome to Debcha Moments. This is another episode on electrical awareness, and we are continuing to share with you some of the things that will help you save money while using your tokens, using your electricity, using your gadgets at home. We are helping you ensure that things are fine and you are safe in your home even as you use your electrical gadgets. I am David Otieno and I am with my friend Kama Kawaida, Jeroboam Kimtai. How are you?
I'm fine.
How has been your week?
The week was good.
Yes.
How about yours?
Mine has been fine.
Great.
And I'm happy seeing you again.
Happy to see you too.
As we continue also talking to the people there.
The people there, yes.
Yeah.
And they are watching.
They are watching.
They are listening.
And we are happy for the responses we are getting also.
Yes.
We
are happy for them too.
Yeah.
For choosing to watch this channel of ours.
Yes.
And to consume this content.
Yes. Thank you so much.
Welcome.
Now, right into it. Today, what do you want to at least stress on or recap on as we continue the discussion? Today I want us to talk about electrical shock, because there's a bit of a problem when it comes to hazards.
Yes.
So today I want us to dwell on hazards. Yes. Before we get into it, what do you think you can be able to stress on with respect of what you've learned in the past?
Okay, as you have said, we will be talking about electric shock. Electric shock. And alongside talking about the electric shock, we shall meet things that we always meet, but today I want us to understand very well. And our friends will follow us slowly, walk with us slowly, and this thing will help you out there. We shall talk about live conductors. That is what we shall stress on. Live conductors. Okay, and in other nations also, I almost said other jurisdictions. In other nations, we have line and hot, meaning live wire, and then we have also return. Return, that's another word we shall stress on. And number 3, which is almost like the second one, this is a safe return. Now, return is a neutral wire, but a safe return is the earth wire. Those are the things we shall meet as we talk about the electric shock.
Wow.
That is it.
Thank you so much. Now, can you tell us more about the types of electrical hazards that we have?
Okay.
Yeah.
When we talk about electrical hazards or electrical injuries that we may encounter, there are majorly 4. One is electric shock. Electric shock.
So that's where you find yourself, you've touched on the live wire.
We've touched on a live wire, a live conductor. Or the casing of an appliance that may be by fault has electric flow of live. So that is shock. And then we have burns.
Yeah.
Okay, you can be shocked, and the point where the conductor was can burn you. Okay. And then we have the third one, electrocution. This is bad. Electrocution.
So what is the difference between electrocution
and electric shock?
And electric shock, or
when we talk about electrocution, that is the case where the person is no more. The person, the killing by electric shock is electrocution.
Yeah.
Yes.
So it's different from the small current. From the bulb.
From the bulb. That one. Okay. But by the way, you are asking something that we are going to go through today about the bulb, the amount of energy that can shock someone to death. We shall equate it to as given amount of power. So the fourth one now is fall caused from the shock. You can be shocked and then you fall. When you fall down, you may be injured.
Yeah. So there are 2 of them now. You're shocked and then you fall.
And then you fall again. Those are 2 different injuries, though caused by shock. So major injuries are 1, electric shock, 2, burns, electric burns, and then 4 is the fall from the electric shock. And then I've decided to put electrocution to be the last one. Yeah, it's a bad thing. Now, we are talking about electric shock because this thing has become rampant. and it is killing people. Unfortunately, I have a case study today that I can do for our viewers,
yeah.
for us to take this thing very seriously. This week, if I may mention, courtesy of tuko.com, Tuko did a story, and they informed people about a teacher who was teaching in a school in Bungoma. I will not mention the name of the teacher, but I may mention the school. The school is called Kimugui Secondary School, somewhere in Bungoma. This teacher...
You seem to know those areas.
I know.
Okay.
I know.
Okay.
I'm a fan of knowing places, especially in our nation, this lovely nation. So that school is called Kimugui. The teacher was teaching there, but this teacher had not yet graduated. He was waiting to graduate from the university, Egerton University. Okay. Now, one morning, this teacher was found dead.
Oh.
And this was due to the electrocution. Okay. Okay. It was reported that he charged his phone, then he forgot and slept. So on waking up the following morning, because I think he was sleeping alone. He used to spend alone that night. He died just like that because of electrocution. Now the details as to how the charger killed him, we don't know. But that is one of the things that we need to talk about. Yeah. Electrocution is real.
Yeah, because I was wondering now what happened. Did the phone blow
or something? No blow. No blow. Maybe it was close to him somehow. Something happened.
Close. Because on the same note, we have a person from our church. He himself, now there was a problem with the charging.
Yes.
Mfanyikazi aliamua kucharge phone with a faulty charger.
Yeah, faulty charger. Get it.
And then there was something, an electro, like I think it shot.
It shot, yes.
And produced fire.
It's very possible.
And the whole house burnt.
Yeah.
And it was so bad.
The charger has components. And one of the dangerous component in a charger is the capacitor.
Or capacitor.
You know, the capacitor stores charge. It stores charge. It stores. So that if there is an interruption of electricity, the charger should be able to continue supplying a constant supply of charging voltage. Right? So this charger has that capacitor, and this capacitor is equivalent to a battery. Though it discharges quickly. So normally what explodes in a charger is that capacitor.
That capacitor.
Should it be faulty, it must explode. It can kill one. I also saw on YouTube someone had a phone here and dead. Right? So such incidences are there.
They occur.
They occur.
Okay.
Are you getting it?
That's dangerous.
And then in 6th July, this is another second case. 6th, I think it was 6th July this year, 2021, somewhere in Webuye. A Kenya Power personnel was working on the lines, and then he was shocked by electricity. But good enough, this one was rescued.
Oh yeah, okay. Yeah. He was at least
he was rescued.
Electrocution did not affect him.
Now it did not reach the point of electrocution.
Yeah.
Now when we talk about electrocution, somebody has died.
Fatal.
Yes. When you are shocked, it means you are still alive. But when you die from shock, it means you have been electrocuted. That is the difference now.
Now I get
all right. Now today, as we have mentioned about the injuries, we can encounter electric shock, the burns, and then the fall from electric shock, and lastly electrocution. Today we shall talk about electric shock alone.
Electrical shock.
Electrical shock.
Tell us more.
Now, electric shock is said to have occurred when a person is part of the electric circuit. When you are part of the electric circuit.
You're part of the system now.
Part of the system. You know, electricity always flows and only flows in a complete circuit. So what completes the circuit is both the line, the live, and another name of the line and live is hot. If the hot conductor or the live conductor does not have neutral, then that is not a complete circuit. All right? So you must complete the circuit for
you to be shocked.
That is the thing.
Tell us about the severity of electrical short.
Okay, the severity of the electrical shock depends on the following. Number one, the amount of current that flows through that person that is shocked. That is number one. Maybe 10 amperes, 20 amperes, 32, 6. Okay.
So they differ.
They differ
depending on the line or
depending on the circuit.
Current. Why should they be different?
They're different because we have the current that is assigned for lighting is lower than the current that is for the sockets, and the sockets is lower than the current for the cookers. Something such illustration. Okay, you may be shocked from the current from the light. So that severity will not be compared to the shock that you receive from the current from the cookers. Right? That is what I mean.
Okay. I get it. Okay.
Another thing is the part. The part through which the current flows through to a human being.
What do you mean? What do you mean about that?
You remember people used to test batteries by their tank.
Unalamba kama inakuchoma kidogo.
You can only feel that the battery has a charge by your tank. Okay? But you cannot feel with your hands.
All right?
So, likewise to electricity. The magnitude of shock is quite severe when you use some place like the tank or any wet place, or when your hands are wet. So with your leg it's different from your hands. And then should it be in the hole of the ear, that's another different case, something like that. The tongue. So the place through which the shock goes through will determine the severity of the shock. Yes.
Okay, so it depends, it falls where? If you hold it,
yes,
on your head,
yes.
If you lamba,
name them lamba. Until they leaked on the batteries when people discovered there was a charge or not. Meaning the tank is very sensitive to shock or very sensitive to the charge or voltage.
And that's a great one.
That is it.
It's a great one.
Number 3, the length of time that you have contact with that live wire or a live contactor. So short time is better, but when you hold on it for some time, you can get killed.
But I'm told that if you're shocked, you may not even be in a position to remove yourself. What happens?
It depends. Let me do some illustration. Nowadays, when you see the poles of electricity, the Kenya Power electricity poles, after some like 1, 2, 3, 4, 5, 6 poles or so, you will get a wire coming from the lower line going down to the ground. And then you will see, if you are very careful, you will see some tag there on the pole, PME. Okay.
What about that?
That one is the earth label. Okay. It is multiple earthing. Okay. PME means protective multiple earthing. Okay. So long ago there were no such earthing. Okay. So when you are shocked, it means you are returning power to the nearest source.
So you are the conductor to the
conductor. So without those lines, it means you are returning power to the generation company wherever it is, very far. So the farther the source, the severe the shock. Okay. But when you get that earth somewhere close to your home or close to a place where you have been shocked from, it will simply leave you. Okay. Or make you fall. Yeah. Okay. So that is the importance of the protective multiple earthing, PME. So that is the difference. But long ago there were no such.
So that's why now if you get caught, you remain there.
You remain there. Another thing is it depends. Have you been shocked with the low volts? The power that has not gone through the transformer is the different from the power that is coming from the transformer. So that big power.
So transformer either steps it down or
steps it up. Now I'm talking about the transformers for the supply. That one is a step down from 33 kilovolts or 11 kilovolts to 240 volts or 220 volts.
The one that now comes into the domestic use now.
The domestic kilovolts means 1,000, okay? So if it is 33 kilovolts, it means it is 33,000 volts. Now it is stepped down to 240. Okay.
Yeah.
Now the shock of that wire of 11 kilovolts or 11,000 kilovolts is more severe than this 240. Another thing, there are no PMEs on those big wires. Protective multiple earthing. Protective multiple earthing are connected to the wires after the transformer. After the transformer.
Okay.
Yes.
Wow. Wow. That's a good information.
The length.
That's a good information.
We were talking about the length.
So length of time.
So
we've talked about the current. About the length of time.
And then the part through which it flows.
The part through which it flows
to your body.
Anything else?
The last one is the resistance of the body against the flow of current. Remember the last episode? I mentioned something small. It depends. Dry hands, we will not be shocked so much. But wet, or if the conductor falls on a cut place, you will be shocked more. So wet hands and a cutting on your body, should the current flow there, you'll be shocked more. But dry hands are good. Okay? Yes.
Anything else that we want to add on
now I was saying about I wanted to illustrate about the current that can kill a person. For example, a bulb may require 10 amperes.
10 amperes.
To operate it. The current necessary to operate a 10 amperes bulb, okay, is 10 times or 8 times the current that is required to kill someone.
Come up again.
Okay. This bulb, it is using 10 amperes. Okay. 10 amperes is way far much good on you. It is very bad. It is 10 times. So you require 10. You require actually 1/10 of amperes to kill you, as long as you hold on it for more than, say, 30 seconds. Okay. So the current necessary to operate a 10-watt light bulb, okay, a 10-watt light bulb. By the way, we are talking about 10 watts. So if you do the calculation,
because 10 watts is a very
listen, let's go slowly. 10 watts. Okay. You remember Ohm's law?
Yes.
No, let's not go to Ohm's law. When you want to get power from electricity, you multiply voltage and current. All right? Now we have 240 volts. Okay? And then we have how many watts? 10 watts. Okay, we want to get the current there. All right?
Okay.
Yeah,
okay.
So you do that mathematics, then you get the amount of current that will kill you.
That is flowing.
That is flowing. So if 10 watts is equals to 240 times X, it means it will be 240, okay, to get that current. It will be 10 divided by 240. So you will get that amount of current that can kill a person. All right, you don't require a big, yeah.
So current is so much dangerous.
It is dangerous, especially alternating current. It moves in different directions. It's not like direct current.
Oh, it's not like the battery one.
Yeah, the alternating current moves to and fro, back and forth like that. So
that means that we have no option but to ensure that we are safe.
We are safe from any conductor.
Any conductor.
Yes.
We should naked wires should not be left unattended to.
No.
We should close them. Insulate them. Close them up.
Operate with your dry hands. Yes. Otherwise, these things will kill us. We are getting supplied with electricity day in, day out.
So mwenye tunasemanga ati mwenye bulb ni kidogo kumbe my friend. So it's dangerous. You hold on it for 30 seconds and you fall there.
Yeah, you fall there.
It becomes fatal.
Yes. You are electrocuted. Now, let's go to the ground and the earth. We said we were going to encounter about the life and the return. We have talked about return in extensive illustrations about even the PMEs. Let's talk about this safe return. Safe return is the earth. Now, safe returns come in a place where you are shocked, but you are not shocked with the live conducting wire, but you are shocked by the casing of the machine, like cookers. Cookers have the casing, a metallic casing. So in one or another, life can go into that casing. So if you have earthed that casing, you shall have a safe return, and you will not feel the shock. Ever heard of somebody saying, I'm getting shocked by everything in my house?
Yeah.
You touch a sufuria,
Yeah, you're shocked. You're shocked. Yeah,
that results from the gadget or the mostly cookers that are metallic. Okay, should there be any leakage of life to the casing, then it will flow to the whole house. But if that casing had an earth wire connected to it, we call it bonding, connected to it, then you will not feel it. Why? Because the earth does what we call safe return to the ground. Before you touch it, it is safe already.
It is safe.
Yes.
So earthing is very important.
Earthing now, therefore, is very important when you want to avoid shock. I think that marks out the end of our discussion.
Wow. That's powerful. That's powerful. Now you know. Let's ensure we are safe. Always ensure that no naked live wire is left unattended. Please close them up. Ensure that you use the insulating tape.
Insulation tape or insulating tape.
Yeah, insulation tape. Make sure you cover it and ensure that no naked wire is there. Mjua kuna wanaume unaweka waya hivi. Weka spele wa shule. Maboys. Kwa shule ati you are there. This is the insulation or the insulating tape.
Usitumie cello tape, the transparent cello tape.
Ungine natumia masking tape.
Tumia insulation tape.
Yeah.
Tutadiscuss kwa nini insulation tape ni mzuri.
Yeah, that's very important. Tafadhali
iko na kitu inaitwa plasticity. Lakini hizo vitu zingine hazina. Yes.
So tafadhali usiweke waya, wengine unaweka waya alafu anakuja anaweka hivi. Inahangisha hivi. Tafadhali utakuwa shocked one day, it will be fatal, it will be too late. Tafadhali ensure everything is okay, close up everything, use insulation tape to ensure that no live wire is left unattended. Yes, I hope you're learning something. Please drop us a comment down there if you're learning something, and thank you so much, brother Jeroboam Kimtai.
Thank you so much, brother David.
Yeah, I'm learning a lot.
We are learning too.
Yeah,
the more we share, the more we learn.
Yeah,
that is great.
Thank you so much for joining us. Please subscribe and share this video to help others also. Otherwise, bye.